Quick, what was the name of your kindergarten teacher? What about the color of their hair? Or the tone of their voice? As you recall the face of your past instructor, thousands of neurons are firing in your brain to retrieve all those past details. Hi, I'm Nicole, and we're about to embark on a journey analyzing how our brains are able to remember both your elementary school's mascot and your friend's birthday party last week all at once. As I speak, your different sensory systems are each taking in different inputs of information. Your ears and auditory system are processing the way my voice sounds. Your eyes and maybe your visual processing are looking at the color of my eyes, or maybe even the messy layers that I cut into my hair. All of these different processes are synthesized in your hippocampus, the part of your brain responsible for processing spatial perception. The hippocampus translates all of these different inputs into one experience. A nerdy Filipino-American girl talking about brain science. This process in which memories are inputted into our brain system is called encoding, the first stage of the memory process. The second part of memory is storage, or storing all of those memories into our brain. But before we can really store memory for good, our memories are often first stored into short-term memory. Typically, our short-term memory can only hold around 5 to 9 memories at a time. But when a memory is deemed important enough, or you're exposed to it enough times, we turn it into a long-term memory, in a process known as consolidation. Long-term memory has almost unlimited storage and are often the memories that we can remember the most. When long-term memories are stored, each memory creates a unique path of connections, or synapses, across different brain cells, or neurons. However, memories themselves aren't really stored neatly, and rather scattered across these multiple brain cells. That leads us to our last stage, retrieval. Retrieval is when we try to, remember something. When we search for a specific memory, we look at the specific path of synapses that memory created. Each synapse connects a neuron from varying parts of the brain that each hold a different piece of the memory. A neuron in your visual cortex might store the cool way I twirl the drumsticks, but a neuron in your auditory cortex is the only one that can register the rhythm I'm actually playing. Then, when you try to recall this memory, the memory is formed when these neurons are fired in a specific pattern using electrical signals sent through the synapses this memory created when it was first stored. And once that specific sequence of neurons fires off, then we can recall the memory. And the more we revisit and activate this pathway in memory, the quicker and clearer you can recall this specific memory. That's why students use flashcards to study before a big test. However, all of this is still a work in progress. Our brains are incredibly complex organs, so neuroscientists are still figuring out all of its intricacies. Like, why do we recall memories subconsciously? And how do neurotransmitters play a role in retrieval? This is still an evolving field, and it takes future scientists like you and me to help it grow.